Okay, so introduction to sets. Now we know a set is just a group of elements or a group of similar objects. Now when you're representing sets, you can represent them as elements or as a range. So if I write set A, let's say it is, you see these brackets, these are called curly brackets. I say 1, okay, I say 2, I say 3. This is set A. The brackets you are seeing here, we call them curly brackets. These represent elements, okay, elements. Now let me just write 2 so that you get the understanding what I'm saying. Let me say 1 and then I write 4. So here we're talking about elements 1 and 4. Now if you have got the set, let's say we have got set B, and then they've written like this. Look at the brackets I'm using, 1 and 4. These are not elements. This is a range of values. So we're talking about all numbers between 1 and 4. Who can tell me those numbers? Numbers between 1 and 4. 2 and 3. Okay. Anyone else? So you can't list numbers between 1 and 4. You also have 1.01, 1.001, 1.5, 1.6. You can't list numbers between 1 and 4. So when you are using intervals, these are sets that it is difficult to list, like very difficult to list. But here we're only talking about the number 1 itself and the number 4 itself. These are elements. This is an interval. So you can't list. If they said list set B here, you can't list that set. It's impossible. Why? Because that's a range of values. It doesn't end. Okay. So what we want to understand mostly here is a range of a function, like the range of values of a set. So we have got different types of brackets. If you see these, we have got A comma B. Those which look semicircular, these are called open intervals. Okay, this is an open interval. Now the number which is written first should always be smaller than the number written second. Okay, like this should be A is less than B. So A can't be equal to B. Like if they are equal, why write it 2 times? You just write it once. So A should be smaller than B. Okay, for example 1 and then comma 4. Those are in open intervals. And then you also have these brackets. If you see them like this, these are closed intervals. Now the meaning of closed is that you are including B itself, you are also including A itself. But for open, you are not including A, you are not including B. So you can start with this and then you put that. So this is going to be called open closed. So this is an open closed interval. You can also have this. You start with this one and then this one. This is a closed open interval, meaning that this first number which is here, we are including it. The second number, we are not including it. So that's the difference when it comes to these numbers or these intervals. So let's say we've been given an interval. Let's say they've written like this, 1 comma 6. You want to write this on a number line. So on a number line, you are going to have 1 there, you are going to have 6 there. Okay, since at both 1 and 6 it is open, those brackets we are saying are open intervals, you are going to put circles and then you write a line like this. So that is how you represent this set. So every number, as long as it is between 1 and 6, is part of this set. But you are not including 1 itself, You're not including 6 itself. Okay? So I don't know the number that is closest to 1 but not 1. You can say it's 1.1. You also have 1.00001, 1.00000. So you can't tell what the number that is closest to 1. All you are saying is that you are talking about all numbers from 1 up to 6, but not including 1, not including 6. So if this set was like this, 1 comma 6, it would be different. So for this one, you'd have 1 here and then 6 here. You are just going to put dots here. Why? You don't connect them because these are elements. You are just talking about 1 and 6, not a range of numbers between those. This is very important to understand because if you join this, meaning anything that you're going to do is automatically wrong. Okay, so it is from this knowledge that you should be able to work out some basic operations. Let's say we've been given the set A. They have said it is from, let's say, -2 up to 4, like this. And then we've been asked to find a complement and show it on a number line. And then the next one, let's say they've asked us to find a complement union A. The other one, let's say they've asked us to find a complement intersection A. So how can you find those sets? So first I'm going to put the set on the number line. We are talking about numbers from -2 up to +4. So you can see at -2, this is closed. Okay, this is closed. So I'm going to put a dot. For closed, you put a closed dot. And then at 4, you are going to put open. Okay, we are going to put open there. So join these. This is a set A. That's the set A. So for question A, you want to find a complement. A complement means what's outside A. Now you can see since in A at 4 it is open, mean that a complement is going to be closed here. Okay, and then we are going to go in this direction. And then at -2, you can see that for A, -2 is included, meaning that outside it won't be included. So you just put an open circle and then you are going to go like this. You are going to be going in this direction because you want what is outside A. So this is a complement, the one you can see in green. So to write now your a complement, when you're writing intervals, always start with the smallest number. So where the arrow is going is to negative numbers and you don't know where it is going to end. So I'm going to just say negative infinity. You don't know where you are going to end. And then where the arrow is going this side, it's positive numbers. You don't know where to end, so just say infinity, it's positive infinity. So I'm going to say a complement is equal to the smallest number you have is negative infinity. Okay, negative infinity. And then you are going to come and reach at what? -2. So at -2 I'm going to put this bracket. Why? Because I'm not including -2 here. Now infinity is never included in a set, so for infinity you always use this, always. Okay, and then I'm going to say union. You can see at 4 we are including 4, and then comma is going to what? To infinity. Infinity is never included in a set, so you put that. So this is a complement. Are we good? Yes, math.
So sir, it will be wrong if after writing this one, okay? Then we say it is then equal to open the open brackets.
Mm-hmm.
Then we write the negative infinity again, another open comma, another open one, then with a positive infinity inside.
That
It's going
is,
to be wrong.
yes, that is going to be wrong.
Oh,
All right. So this is a complement. Yes, Kristen. So if you look at this set, what is outside, you have got this part, right? You also have this part. Both are outside the set A. So whenever you are joining, like this is outside, even this is outside. So to just join these two which are outside, you are going to use a union. That's the union you are able to see on the middle there. Is it okay? Shekaina, where is this girl? Are you understanding? So let's look at this one. A complement union A. Now, whenever you talk about a complement of a set, together union is combine it with the set itself. So what you are able to see is when you're talking about the complement of a set, union means combine two sets, okay? So always start with the smallest. So I'm going to start from here. So I'm going to be writing like this, like that. Now if you say at negative 2 is not here, right? But the negative 2 is here, meaning that these are going to join. It's more like, Martha, you have got a 20 kwacha. I don't have anything. When we meet, we can buy something and we're also both going to enjoy. All right, so same with this. You have got a negative 2 not in the set A complement, but negative 2 is in the set A, meaning that these you are able to join them, right? You are able to join them. So that is going to be a connection like this one who has plus what is who doesn't have. Because someone has, there's going to be that connection for you to be able to buy something because someone has, even if you don't have. So we're going to connect, we're going to continue like that. So that's union, you are combining. Same, A now doesn't have, but A complement has. So still they are going to connect here, okay? They'll connect. So what are you seeing? The arrow is going all the way this side and it's going all the way this side. Meaning that A complement union A is a set of all real numbers. Alright? So like it's everything. So whenever you have got a set union its complement, it will be from negative infinity to positive infinity. So all the elements between are going to be part of this set. And then if you look at A complement intersection. Yes, math.
Sir,
Yes.
what are those open brackets, closed ones, or are they gated? No, no, they're not gated.
No, these are open.
Oh, you said for infinity it's always open.
Yes, infinity is always open. Alright, now for C, you want to look at A complement intersection A. Now, intersection is where two sets are meeting. Look at this. These are the only 2 points which you are able to see there is meeting, right? Here and here. That's the only point where there is meeting. Now, the set A complement doesn't have negative 2. The set A has got negative 2. Christine, what do you think? Are they meeting or not? Are those two sets meeting?
I didn't get the question, sir.
So negative 2 is in the set A, but it is not in A complement. Are these two sets going to meet or do they have common elements? So there is nothing common. Okay, like you meet someone who doesn't study, you study. There's nothing common between you people. Okay, in terms of studying. So there is no intersection between these two sets, though they can be a union. You can combine them because if you combine someone with someone with nothing, you're going to have something. So union, it's possible, but intersection, So A complement intersection A is an empty set, right? A complement intersection A is an empty set. I hope that is okay. Now, from here, there are some things that you really need to understand, because these are the things that make sets a bit of trick to some people, and trust me, to be triggered sometimes if you don't understand this concept. So let's say I've got the elements from 1 up to 4. You have got a set which is coming like this. Okay, starting from somewhere there, let me just put an arrow. It reaches here. And then you have got another set which starts also here. It goes in this direction. Let's say this is set A, this is set B. Now you want where these two sets, so you want to find A intersection B. So the intersection of two sets is where those sets are meeting. What do you think? Are these sets intersecting? Are they intersecting?
I would say yes, because no,
Mhm.
they're not intersecting because one is not included in both.
Okay, one is not in the set A, one is not in the set B. So obviously there is no intersection. So the intersection is an empty set. Okay, and then if you want to find A union B, now the union means combine two sets. Okay, the union, you start from here. Okay, you also add this set. Now notice that at 1, like 1 is not in any of the two sets, meaning that it can't be even in the intersection, like it can't be in the union, it can't be there. Okay, you can only combine something that is available. You can't combine nothing with nothing and you expect to get something. So 1 is not in both sets. In other words, the union of these two sets, you are going to be coming from negative infinity. Okay, from negative infinity, and then you are going to reach at 1. You are going to pause at 1, and then at 1 you continue moving to positive infinity. Why am I pausing at 1? Because 1 is not in any of these two sets. That's why instead of me just writing from negative infinity to positive infinity, I pause that 1. If I just write from negative infinity to positive infinity, it is going to be wrong. I hope that is okay. Now, same, if we had this same thing we have here. Now one of these sets is shaded. Let's say one of these sets is shaded like that. We want A intersection B. A intersection B, these still, they don't have anything in common because one includes an element, the other one doesn't. So this is going to give us an empty set still as an intersection. But union, if you talk of A union B, because of this one who has, they are able to connect with this one who doesn't have. Okay, union means combining, so they are able to combine. So there is going to be a connection and there's going to be a link. So you see that the union is going to be from negative infinity to positive infinity. Why? Because at this point there's going to be a link. So that's the difference when they are both open. Okay, so if they were both closed there, if they are both closed like that, things are going to change for their intersection. So if they are both closed, you can see that this element 1 is common in both sets. Like the element 1 is in set A, it is also in set B. So the intersection is going to be 1. But because this is an element, it's not a range of values, we are going to use curly brackets. If you use any, you only use intervals for two values, a small one and a big one, which are in a range. Okay, and then A union B will still be from negative infinity to positive infinity because there's a connection here. Are we okay? Yes, Kristen.
So a set that has been given, that is shown by curly brackets, cannot be expressed or found by using a number
You can use a number line. I'm going to show an example of that. Yes, Martha.
So say in any case where you just find one number or rather one element, you're always supposed to use the curly ones.
Yes,
It's the only
always.
it's okay. Okay,
Always.
only is it the only is it the only scenario where you get to use the curly ones or what?
No, there are different scenarios. Let me maybe use another example. So let's say I've got a set A, and the set A, let's say we have got from 1 up to 4. I'm going to put this open and then this closed. And then we have got the set B. Let's say this one, they've told that it is 1, comma 2, comma 3. So you can see the difference. There you have got curly brackets. Okay. So the first one, we're going to find A intersection B. Now the best to you for you to work out this, use a number line. So I'm going to write a number line. For the first one, we're talking about elements from 1 up to 4. So 1 is not being included for the set A, right? And then 4 is part of the set A. So I'm going to connect this. So this is the set A. Now the set B, you can see these are elements 1, 2, and 3. So for the set B, those are elements. They are not ranges of values. So for the set B, you are going to have 1 as a point, 2 as a point, 3 as a point. This is the set B. You don't connect them. Why? These are individual elements. They are not ranges of values. So if you want to find A intersection B, you want what is common. What can you see in the set A and also in the set B? Now in the set B, you can see the what? The number 1. But in the set A, there is no 1 since it's open there, meaning that 1 is not part of the intersection. In the set B, you can see the number 2. Even in the set A, you are going to see a 2 there because it's part of that set. Okay, so I'm going to write 2. 3 also is going to appear in both sets, right? Okay, like that. I'm using a comma. So here I'm going to use curly brackets. I can't use a range. Why? Because if I use a range, it means that even for the set B, we are also talking about all the values between 2 and 3. So the intersection of elements and the range will always be elements. That's why you are always going to use curly brackets like that. Are we good? Is this okay?
Yes, I get it.
All right. So you guys need to understand this because a lot of people get to mix things here. Okay, they get to mix things. Now let's say the question we've been asked to work out is let's say we've been asked to work out A complement intersection B. So A complement intersection B means what is outside A but should be in B. Now you can see that for the set A, you are including 1, meaning that for A complement, you not include 1, right? So at 1, I mean 1 is not part of the set A, so it will be outside A. So I'm going to shade and then write in that direction. And then at 4, 4 is part of the set A, right? So it's not going to be part of the outside, so I'm going to put open, right? So that is the set A complement. Now you want where A complement is intersecting with the set A, with the set B, I mean here, A complement intersection B. So from what you're able to see, for B we have the sets, the elements, the 3. you can see that 3 is not in a complement, right? You also have the element 2, and you can see that 2 is not in a complement, isn't it? And then you have got the element 1. You can see that 1 is in a complement. So the complement of A intersection B is just going to be 1. And since it's just an element, you use curly brackets. That is how you get to represent that. Okay, let's say we are also asked to find A complement union B. Now, a union becomes a bit of trick. Union means combine. Okay, we want what is outside A together with what is in B. That's union. But intersection means what is outside A but is in B. Right? So A complement union B, what is outside A, okay, together with what is in B. So you can see that what is outside A are coming from negative infinity, that's the smallest. We always start with the smallest when writing sets. So negative infinity, comma, you are going all the way at this point, you are connecting these two sets, right? So you are going all the way up to what? Up to 1. And you can see that 1 is in both sets, so it will be part of the union. Now remember talking about together with B. Now you have these elements in B. These are individual elements. How are you going to write them? You are just going to say union. You have got the elements 2 and 3. Now these are elements, so put them in curly brackets. Okay. And then you also have this region. It is also a complement. How are you going to write it? You again say union, but this is a range of values starting from 4 up to infinity. But 4 is not part of the set, so it's going to be open. And then infinity is also open. So this is a complement union B. And make sure that you are writing them in order, starting with the smallest, after the smallest, and then you go to this, and then you write this. Don't confuse them. You write 4, you write 3, you write no. Write them in ascending order. Is this okay? Do we have any questions? Martha, are we okay?
Yes, so I'm trying to follow, but I don't know.
And these are some questions we're going to find in such an exam where you can even say the exam was an exam anyway. So what of if we want to find A intersection B complement? How can you find? Now to find B complement, look at B. B has got only elements, right? So B complement, we are just going to exclude those elements. The rest are going to be outside B. So at 1 I'm going to put an open circle. At 2 I'm going to put an open circle. At 3 I'm going to put an open circle. And then I'm going to connect these at every point. So here the arrow go like this. Here the arrow go like this. This is a set B complement. Because B only has 1, 2, and 3. Meaning that anything other than 1, 2, and 3 is going to be outside B. Okay, so that's the set outside B. Now you want where it is intersecting with the set A. So B complement intersecting with the set A. So where is it common with the set A? You can see 1 is not in these two sets, right? It's not in those two sets. So I'm going to write 1, but it's not part of the intersection, so I'll use open. Okay? And then we are going to go at 2, we are going to pause. Why? Because 2 is in A, but it's not in B complement. So at 2, I'm going to also open. And then union, from 2 we are also going to continue. You can see these elements between 2 and 3 are within in both sets. Okay, but 3 also is not going to be in both sets. Why? It is only in A, but it is not in B complement. So I write 3. I again close. And then from 3 we'll still continue up to 4, but 4 is going to be part of both sets. So 4 I'm going to use closed. Why? Because it is in A, it is also in B complement. So this is going to be the set A intersection B complement.